What's up, everybody? This is try number 3. We've been having some technical difficulties today with the Wi-Fi and all sorts of stuff, so I'm back now, and we're going to continue with the series on SAT Khan Academy problems, and right now we're actually going to tackle some Khan Academy, another practice test. So this is test number 3, and we're going to do the math no calculator section. Now, unfortunately, I just did it, but the live stream, there was some malfunctioning with the Wi-Fi, and I'm having to redo it now. So this actually, unfortunately, won't be my first time. I just went through all of these problems. So we're going to do it again, and hopefully give you guys some good explanations as we go along. And if you guys have any questions or comments, please put them in the comments below. And definitely, please send me questions, or if there's particular ones that you want me to solve or explain, I'd be more than happy to do that. Without further ado, round 2, let's start the timer, and let's begin. Continue to first question. A painter will paint n walls with the same size and shape in a building using a specific brand of paint. The painter's fees can be calculated by this expression, where n is the number of walls, k is a constant with units of dollars per square foot, a is the length of each wall in feet, and h is the height of each wall in feet. If the customer asks for more expensive paint, which of the factors in the expression would change? So if we have n, k, a, h, this wouldn't change because it's the number of walls. And A would not change because it's the length of walls in feet. H is the height of walls. It's gotta be K. And they give you this weird, vague wording. K is a constant with units of dollars per square foot. K is dollars per square foot of the paint, right? So they're just trying to make it ambiguous, but K is your answer that's affected by the quality of the paint. Let's go with this one. What is 6r plus 3? Well, r equals 6, right? We can see it from that first equation. Plug 6 in. 36 plus 3, 39. Whoops. Number 3, which of the following is this? So what is our rules for exponents, fractional exponents? We go, whoops, what's happening here? We go a to the 2/3. This is your root, and this is your exponent. So this becomes the cube root of a squared, and there you go, which is this guy. Number 5, the number of states that joined the United States between that year is twice the number of, so 1776, and then this one is 1850. It's twice the number of states that joined between 1850 and 1900. So 30 states joined in this period, and X joined in 1850 to 1900, and 30 is, and this zone here is twice the number that's over here. So this is twice whatever this number is. Now I've set up the equation just how they want it. And they said, which of the following equations is true? And we should look for 30 equals 2x. This is almost close. It's this one. 2x equals 30. It's the same thing, but just flipped. Let's do question number 5. We've got 5 over x equals 15 over x plus 20. And we need to first solve for x and then get this value, x over 5. So let's cross multiply. This is a good setup for cross multiplication. When we have two ratios like this, equals 5x, and then distributing the x to the 20 as well, plus 100. Subtracting 5x from both sides, and we get 10x equals 100. Divide by 10, and we get x equals 10. And 10 over 5, which is what we need to solve, equals 2. And you see that they even give the value of 10 up top. That's to trick people. Let's go with this one. This is 2x minus 3y equals negative 14. And this is a system of equations that we have to solve. 3x minus 2y equals negative 6. I'm going to multiply. I'm going to match up we need to get x and y. I'm going to use elimination. We'll match it up in this way. I'm going to multiply the top by 3 and the bottom by negative 2. And we got 6x minus 9y equals negative 42. And the bottom we got negative 6x plus 4y equals positive 12, right? Times the negative 6. And now we add these together. These x's cancel out. Negative 5y equals negative 30. Y equals 6. And then plug in 6 into any of these equations. So let's say we got 2x minus 3y equals negative 14. 2x minus 3 times 6 equals negative 14. This is 2x minus 18 equals negative 14. Add 18 to both sides. 2x equals 4, right? 18 plus negative 14. equals 4, and then x equals 2, dividing 2 by both sides. So so we want x minus y, which is 2 minus 6, right? We're taking these two values here, and we get negative 4. Next question, 7. The function f is defined by the polynomial. Some of the values are shown in the table above. Which of the following must be a factor? A factor occurs where at the zeros, basically the values of x that give you roots, and the only one that does that is here, where x equals 4. Therefore, if we factor this polynomial to zero it out, this would have to be a factor, because we plug in 4 here and we get a 0 for the entire polynomial. That's what it's asking. So we're talking about factors, we're talking about a binomial in this case that zeroes out. Number 8. So we've got y equals kx plus 4, and it's a constant graph in the xy plane and contains a point CD. What is the slope of the line? Basically, what is k? Because k is the slope in terms of c and d. So y equals kx plus 4. Let's plug in c and d into this equation. That's your y value. That's your x value. So we've got d equals cx plus 4. Subtract 4 from both sides. We get d minus 4 equals cx. Divide both sides by c. And we got d minus 4 over c, which is a. Let's go on to this guy, number 9. Kx minus 3y equals 4. 4x minus 5y equals 7, and we want to, so the system above, k is a constant, x and y are variables. For what value of k will a system of equations have no solution? No solution is synonymous with parallel. We want to know what value will make these guys parallel. First, we need to know the slopes to determine what will make them parallel, and to do that, we need to get them in slope-intercept form. So this in slope-intercept form is negative. I'm just isolating y, that's it. I'm subtracting kx from both sides. Equals negative kx plus 4, dividing by negative 3, y equals k over 3, because it balances out, right? Negatives and negatives, minus 4/3. But this is what we care about. So this is the slope of that guy. The slope of this guy is negative 5y equals negative 4x plus 7. And y equals 4/5 x minus 7/5. But we don't care so much about this value, the y-intercept, so I'm almost going to cancel it out just so it's not distracting. We want to know what value of k is going to make this whole fraction equal to 4/5. So basically, how are we going to get k over 3 equal to 4/5? Well, I don't know. Let's cross multiply. We got 12 equals 5k. Divide both sides by 5. K equals 12/5, 12 over 5. Number 10. In the xy plane, we've got this parabola y equals x minus 11 squared. And it's intersecting some line y equals 25. Okay, and we want to know what is at a and b. And we want to know what's this length here, AB. Well, what we have to do is we have to find the x value here, and subtract them, and that will give us the length. So what is the x value? Well, we need to find the two x values that give us 25 for the y value. So let's plug in 25 for y, and we can solve that way. Square root. And now we get, this actually bifurcates into two equations, because square root of 5 is not just 5, it's also negative 5. So this becomes x minus 11, and then negative 5 equals x minus 11. X equals 16, right? Add 11, and then x equals 6 if we add 11. So the difference between 16 and 6, 10. Okay, we're halfway done, and we're pretty good on time. But again, I've seen these problems, so that's why I'm able to go faster. And last time I was doing it, you didn't see, but man, the image wouldn't load, and now I realize I had no internet connections. It wasn't even streaming. Now this is much better. In the figure, so this one I'm doing for the first time. In the figure to the left, lines K, L, M intersect at a point. If x plus y equals u plus w, what must be true? Okay. So let's just think about all these values. Z equals t. So we're saying x plus y equals u plus w. X plus y equals u plus w. So it's saying that these two angles are equal. X plus y, and then hold on, let me see something. X plus y, and oh, this means y and u are vertical angles. So these guys are actually equal. This actually means that x equals w. We know that x and w are equal to each other because these guys can essentially cancel out. So if x and w are equal, which isn't even one of these three, but we need to figure out from that, then which ones can we show. I'm going to actually redraw this here. Hopefully this doesn't take too long. I just want to look at it a little more clearly. So x, y, z, t, u, and w. Of course, these two we've just proven are equal. And that means this is equal to that. This is equal to that. So all of these four angles must be equal because x is equal to t vertical, w is equal to z vertical, and these guys are equal. So all four of these angles are equal to each other. So is x equal to z? Yes, one is true. Y equal to w? No, we don't know that. Z equal to t? Yes. So I'd say 1 and 3. We don't know this one. And I'm going to... Oh, wait. What does it say again? Y equals w. Yeah, that's the only one that we can't connect. So I'm going to go with 1 and 3. And we'll see if that's right. This problem is pretty crazy. So in the quadratic equation above, a is a non-zero constant. The graph of the equation is the parabola with the vertex CD. So this took me a second to figure this out when I did it last time. So it's like here's CD. And we know from the way that it's factored, it has zeros. The zeros are going to be at x equals 2 over here and x equals negative 4. And because this is going to be symmetrical around the vertex, we know the vertex is going to be right in the middle at negative 1, right? That's right in between negative 4 and 2. So now we can plug in negative 1 and calculate what C and D are. Actually, no, we already know what C is negative 1. We can calculate what D is based in A. So look, we just plug it in. Y equals A times negative 1 minus 2 times negative 1 plus 4. And this is A times negative 3 times 3, which is negative 9A is D. Yeah. Let's do this one. Oh yeah, this one is pretty crazy too. This took me quite a while, so let's see if I can do it faster this time. All we're doing is we're taking all this craziness and we're solving for A. That is it. So the way that we can do it is like this. And again, there may actually be a way faster way to do this than what I'm going to try and do right here. Because it took me a while, but it works. So we're just going to go with it. Equals negative 8x minus 3 minus 53 over ax minus 2. So what I'm going to do is I'm going to multiply everything by ax minus 2. That's going to get rid of this denominator, 24x plus 25x minus 47 equals negative 8x minus 3 times ax minus 2, right? We're multiplying against this binomial and this binomial. Minus, and then this crosses off this guy too, minus 53. Now let's add 53. Let's get rid of it and move it over here. So we got 24x squared plus 25x minus, that would, or no, plus 6 equals, and then I'm going to FOIL this, okay? Just because it'll be better. And then we can get closer to our final answer. Negative 8ax squared plus 16x minus 3ax plus 6. Okay? We can immediately cross these guys off. Mirror images, same side. Let's subtract 16x as well. So now we got 24x squared plus 9x equals negative... And I'm gonna so this goes away. Yeah, let's do it step by step. Negative 8x squared minus 3ax. Let me move this down up a little bit. And now we can factor out an a. A is negative 8x squared minus 3x, and we're gonna set that equal here. And then all we gotta do is we just gotta isolate by dividing. A, so we divide both sides by negative 8x squared minus 3x. Negative 8x squared minus 3x. And you notice that really nice, as crazy as this is, this goes in exactly 3 times. This binomial goes in 3 times to this, or negative 3 times. So our answer is negative 3. Crazy problem. Very hard. They get harder as they get close to 15. What are all the solutions of this? I can look at the answers and say, we're not factoring. This is all quadratic. So first I'm going to divide the polynomial by 3, x squared plus 4x plus 2, and I'm going straight to quadratic. I'm not even going to mess around. -4 plus or minus square root of b squared minus 4ac, which is, this is 1, this is 2, times 4 is 8, over 2a, which is 2. 16 minus 8 is 8, -4 plus or minus square root of 8 over 2. Pull out a 4 from this, which comes out as a 2. 2 square root 2 over 2. Divide both sides by 2. We get -2 plus or minus 2. And that's A. Oops. Next question. Alright, this is a pretty crazy one. What's basically going on is they're giving you the equation. This is the real equation to convert between Celsius and Fahrenheit. So this is what's happening, and they're saying which ones of these are true. A temperature increase, this is all about interpreting an equation. A temperature increase of 1 degree in Fahrenheit means that this goes up 1. The Celsius degrees goes up by 5/9. An easy way to test for this is just pretend we plug in 32 degrees and we get 0 for Celsius. We plug in 33 degrees and we get 5/9 for Celsius. Plug in 34 degrees and we get 10/9. So every time Fahrenheit's going up by 1, Celsius is going up by 5/9. So 1 is definitely true. What about 2? A temperature increase of 1 degree Celsius is equivalent to 1.8. 1.8 is also 10/9, by the way. Okay? So, because 5/9, oh wait, no, is that true? Let me think about that for a second. No, I'm sorry, not 10, it's 9/5, excuse me. So they're saying every time Celsius goes up, that's going to go up. Well, it's kind of hard to tell here. I'm going to actually isolate Fahrenheit by multiplying both sides by 9/5. So we get 9/5 C equals F minus 32. We can add 32. It doesn't matter. But bottom line is, now what's happening every time Celsius is going up by 1, is Fahrenheit going up by 9/5? Yes, right? And we can choose a nice value to showcase that. We can choose really anything the way it's set up here. We choose 0 and Fahrenheit is going to be 32. We choose 1 and Fahrenheit has got to be 33 4/5 because it's got to be enough to get us a 9/5 value. So yes, every time Celsius goes up once, Fahrenheit goes up 9/5, which is the same as 1.8. And we can actually stop here because there's no option that says 1, 2, and 3 are true, only 1 and 2. But this is wrong because it contradicts 1. It's saying a temperature increase 5/9 degrees of Fahrenheit is equivalent to, it's just contradictory, so we can dismiss it. All right, let's go on to 16. We got a good amount of time left, a nice solid 8 minutes. Not great for the last 5, but it's okay. What is one possible solution to the equation above? All right, this is how I'm going to do it. I'm going to multiply everything out and set it equal to 0. If you really felt bold, you could guess and check, but I don't think that's the best option. So I'm going to say x to the 5th minus 5x cubed equals -4x. Oops, -4x. Add 4x to both sides. X to the 5th minus 5x cubed plus 4x equals 0. And then I'm going to factor out x to the 4th minus 5x squared plus 4 equals 0. X times x squared. And then this factors into, this becomes -4 minus 1, right? They multiply to +4, add to -5. And this becomes x plus 2, x minus 2. And that's all we need. This factors into this. And this gives us a root of -2 and +2, but we need x is greater than 0, so we can stick with +2. That's all we need to do. This would also give us a 0 of 1, but so 2 or 1 should both be correct. Let's clear this. Solve for this. 7/9 x minus 4/9 x equals 1/4. I'm going to just put it in common denominators. 3/12 plus 5/12. This becomes 3/9 x equals 8/12. And then we can just cross multiply by, or multiply both sides by 9/3. And 9/3 is really just 3. So it's 24 over 12, which is 2. So 2 answers in a row, we got 2. Now this one, cool. So this is what I get to do for the first time because I couldn't see this image last time, it wasn't working. Note, figures not drawn to scale. Two isosceles triangles are shown to the left. If 180 minus z equals 2y and y equals 75, what is the value of x? Well, let's just solve it. So that would be 75 equals 180 minus z. 150 equals 180 minus z. So z is obviously 30. Okay, so we know z is 30, and then what is the value of x? Let's see. Let's solve it like this. Boom, boom, boom. So 30 is here. We've got y is, what was y again? 75. Okay, we know that these are isosceles triangles, and we want to get this value up here. If these are isosceles triangles, right, this angle equals this angle. If this top angle is 30, we know that these two must be 75 because they have to add up to 150, so that plus 30 we adds up to 180, and then these two are supplementary. So if this is 75, this has to be, x has to be 105. Okay, let's enter that. 2 questions left. A lot of time left. 5 minutes. You can slow down a little bit. At a lunch stand, each hamburger has 50 more calories than French fries. If 2 hamburgers and 3 fries have a total of 1,700 calories, I'm just adding them up. 2 hamburgers, 3 fries. We need to find out how many calories a hamburger has. This is just basic system of equations. Now I'm going to substitute in for f because we want to find h. It saves us a step. So h minus 50 also equals f, right? If we just subtract 50 from both sides. I'm going to plug this in for f. So we get 2h plus 3 times h minus 50 equals 1,700. 2h plus 3h minus 150 equals 1,700. h minus 150 equals 1,700. 5h equals 1,850. Divide both sides by 5. And h equals, let's see, divided by 10 would be 185. Double that is 370, I believe. And we can quickly test it if you want. So a hamburger is 370. Fries must be 320. And if we follow this equation, 2 hamburgers is 740. 3 fries is 960. Yeah, and it adds up to 1,700. So that's right. If you have time, you should absolutely test to make sure it works. Okay, this is the one. So I'm curious to do this because I didn't have proper time to solve it last time as the glitches were happening. So now I got plenty of time. I can go a little slower. So we got ABC. We've got, this guy is 90. ABC. And then we have, it says a similar triangle, which I'm going to just jump ahead and put it down here. Here's DEF. DEF. So the corresponding sides, vertices. So BC, it says, is 16 and AC is 20. And we can actually use Pythagoreans to solve for this, which we will shortly. And then respectively, DEF is 1/3 the length of the sides of A, B, and C. So that means this is 20/3. This is 16/3. And they want to know what is sine of F. So we want to know of this guy. What is sine of F? Sine of F is going to be opposite, which is this value, which we don't know what it is, over hypotenuse, which is 20/3. So we got to figure out this value here. We could just straight up use Pythagoreans here, or we could use Pythagoreans here and then divide it by 3. I'm going to do it here because these are nicer numbers. So 16 squared plus x squared equals 20 squared. That's 256. I have that memorized. Plus x squared equals 400. Because there's no calculator, we can't use a calculator. Subtract 256 from both sides. We get x squared equals 144. Hopefully you recognize that the square root of 144 is 12. Oops. Sorry, this is 12. So then again, divide by 3 to get this side. 12 divided by 3 is 4. So opposite is 4 over 20/3. The way I like to convert a fraction over fraction, I put it over 1, and I'm like, this guy goes here, and this guy goes here for multiplication. So it ends up becoming 12/20, which reduces to 3/5, which is the same as 0.6. I'm going to enter it as a decimal, but you could also enter it as a fraction. So we got 2 minutes left. So this was a pretty hard section. Again, I went pretty fast. Granted, I'm explaining it, so I'm going slower than I could, but this was a hard section, and for me to do it the second time, obviously, it was able to be a little bit more fluid. So definitely very difficult. Let's go ahead and finish this section. And, oh, wait, what? Go back to question 1. Oh, no. All right, finish this section. We're good. Cool. Let's see what we got. And I think, oh, wait, we can review it straight away. Let's see. Cool, yeah, we can review it. Beautiful. So everything that we did was correct. So there's nothing that we need to go over again. So that's basically it. And let me quickly, we're basically out of this. Whoops. Oh, here we go. All right, so that's it for today's live stream. I hope that was really helpful. I hope you guys enjoyed it. And sorry for the technical difficulties before. Just some internet problems was unavoidable. Every Wednesday, we're going to be doing new live stream standardized tests, so make sure to tune in. And if there's specific tests that you want to see me solve or tackle, let me know. Put something in the comments or shoot me an email at huzaifa@scalarlearning.com. And I would be happy to take on additional questions. For now, every Wednesday, we're going to keep plowing through these practice tests from Khan Academy to give you as many options for good, solid explanations as possible. And now with this new setup, I think this is great. You can actually see me while I'm working along it. We always find that talking head videos have a higher level of engagement, so that's a really positive thing, and I'm excited that I've been able to install the software successfully and be able to use it. So thank you guys so much for joining, and I'll see you guys next time. Take it easy.